Hello guys, this is AP Calculus AP class with Mrs. Ryu. Today we are going to finish chapter 1.2. We are going to focus most on when the limit does not exist. Okay, so let's get started. So limit that fails to exist. Example 3 said show that the limit of the function below does not exist. And I have limit as x approaches 0, absolute value of x over x. To find the limit, can we graph this first? Okay, so I have x-axis and the y-axis. And I guess that we can have 3 different cases. So first, when x is greater than 0. Okay. Second, x is less than 0. Third, x is equals 0. In the first case, the positive number is inside the absolute value, so it's just x. Okay, so that is 1. And in the second case, since x is a negative number, when it gets out of the absolute value, it should have a negative sign. So that negative sign and the negative number makes the positive. That's what the absolute value does, right? So it makes it negative 1. What if x equal to 0? Then I guess I'm going to have 0 over 0. What's 0 over 0? Is it undefined? Is it 0? Is it 1 because the top and the bottom the same? No. It is indeterminate. That means we can't decide. Okay, we can't decide. That means it can be any number. Any number. Let me tell you why. Okay, here's a small portion here. 0 over 0. Let's say that that is a certain number, a. Okay, then we can multiply 0 on the both sides. Then I'm going to have 0 equals a times 0. What can the a be? Any number, right? It makes sense for any number a. That's why 0 over 0 can be any number. It can be undefined. It can be 1, 2, 3, negative. It can be any number. So that's why we call it an indeterminate. Okay, now let's graph this function. So x is greater than 0, so that's 1. X is less than 0, that's negative 1. And the x equal to 0, that's indeterminate. In this case, we're going to just leave it as a whole, okay? Because sometimes it's undefined. We're going to talk about it later. Okay, now, what's the limit of the function? Is if you go to the go from the left, then that's negative 1. If you go from the right, then that's 1. So which one should we write? Should we write both? The answer is no. Answer is D and E, which means the limit does not exist because okay, the left side is not equal to the right hand side. So limit does not exist, and then you write D and E. This is the first case of the D and E. Example number 4, it says, discuss the existence of the limit. And I have a limit as x approaches 0, 1 over x squared. So let's have the x-axis, the y-axis. Let's graph this first, okay? But before that, what is the parent function? I would believe that that is y equals 1 over x. So that is a rational function that looks like this. Let me change the color now. Okay. Now, y equals 1 over x squared graph is whatever the x is. So x can be positive, x can be negative. Y value is always positive because it's x squared, right? So our function should look like this. So y is positive, as you see. In this case, right hand side, left hand side, I think it's gonna have the same value, but the thing is, it goes up and up and up and up like infinitely. Okay, so it's gonna just keep going up. So we can't really define it because it's gonna be an infinity. So it's like undefined, right? So when you cannot define the limit, we say that the answer is DNE. We say that the limit doesn't exist because we can't define it. Example number 5 says discuss the existence of the limit, and we have a limit as x approaches 0, sine 1 over x. Can we graph this? Yes, we can. We have y equals sine x, as you guys all know, that looks like this, right? Then what about y equals sine 1 over x? It's kind of challenging, so can we draw the table? Yes. So x and sine 1 over x. Let's start with something about like 90 degrees maybe. So in x, we are going to put, instead of a pi over 2, how about 2 over pi, because the angle here is the reciprocal of the x, so we just want to put it upside down. So then I'm going to have sine 1 over 2 over pi, so that's sine 90 degrees, right? So what is sine 90 degrees is 1. Okay. How about I would like to use something like 270 degrees. So I'm supposed to put 3 pi over 2, but in this case, again, things are upside down, so I'm going to put 2 over 3 pi. And the sine 270 degrees is -1. Okay. How about we go with 2 over 5 pi? That has the coterminal angle with 90 degrees. So that's 1 again. 2 over 7 pi. That is a coterminal angle with 270 degrees. So that's -1 again. So let's say this point here is 2 over pi. Okay. And it's 1. Now, if you divide this distance into 3 equal pieces, that's 2 over 3 pi, right? Then you're going to have a -1. So we have 2 points so far. Let's keep going. I changed the color here. Now let's divide this distance into 5 equal pieces. Okay, is it 5? Okay, then I'm going to have 1 again. Okay, if you divide this distance into 7 equal pieces, then you're going to have -1. So pretty much you have graph something like this. Okay, the question is, what's going to happen around 0, near 0? The answer is, it's going to oscillate faster and faster and faster. So this part here is kind of wide, but as it gets closer and closer and closer to 0, it oscillates more and more and more frequently. Okay? What if it's right next to 0? Then I think it's going to oscillate like infinitely frequently. The other side is the same. First it goes kind of slow, then faster and faster and faster and faster. So the graph looks something like this. So I don't think there is a hole at the origin, because it's going to go, it's going to just oscillate more frequently, and it never stops. So the answer for this question is DNE again. This is the third case of DNE. When it oscillates between two fixed points, we can't find the limit. Okay, what about y equals x sine 1 over x? Okay, can we find the limit as x approaches 0? Okay, so let's graph this. I think it's kind of similar to the previous problem, but the amplitude here, let me change the color. Amplitude is the x, right? So that means around 0, it has a very small amplitude. But as x gets greater and greater, the amplitude is greater too. So in this case, the limit as x approaches 0 is 0. So very similar to the previous question, but the answer is kind of different. So let's make a summary. When you write DNE as the answer, we had 3 different cases, right? So number 1, what was it? When you have right-hand side not equal to the left-hand side. That was number 1. So remember that we had a function absolute value of x over x. And number 2, when you had the undefined answers like this. Okay, so remember that we had an example like 1 over x squared. What was number 3? When you have the graph that oscillates between two fixed points. Okay, so the example was the y equals sine 1 over x, but the non-example was y equals x sine x, 1 over x. So in this case, the answer was DNE. Okay, DNE. But in this case, the answer was 0, right? So it was different. Here is a Bible verse of the day. Create in me a pure heart, O God, and renew a steadfast spirit within me. Psalms chapter 51, verse 10. So I'd like to encourage you guys to walk with Jesus today. Bye!